Okay, this is example 6. The water level relative to the top of a boat dock varies with the tides. One day, low tide occurs at midnight and the water is 7 feet below the dock. The first high tide of the day is at 6 a.m. and the water level is 3 feet below the dock. The next low tide is at noon and the water level is again at 7 feet below the dock. Assuming that the pattern continues indefinitely and behaves like a cosine wave, write a function of the form w of t equals a cosine of bt minus c plus d. The value of w of t is the water level in feet relative to the top of the dock t hours after midnight. So we know that at midnight, which would be 0, t would be 0 then, we know that the water is 7 feet below the dock. So w of 0 is going to be -7 because the water level, we're thinking of the top of the dock as 0 feet. So that's where we start. Then it says that the first high tide of the day is at 6 a.m. and the water level is 3 feet below the dock. So at 6, the level of the water is -3. Then it says the next low tide is at noon and the water level is again at 7 feet below the dock. So it goes back down to -7 by 12 p.m. This is the graph. This is showing you how the water acts from midnight to noon. So this is how we understand a sine curve. So we're going to do what we did in the last example, except we're just going to do it backwards because now we have the graph and we have to figure out the equation. So we can start out looking for A. So the midline is going to be halfway between -7 and -3. So it's going to go right through the middle. We know halfway between -7 and -3, the distance between -7 and -3 is -3 minus -7, which is 4. And so take half of that, and that's 2, and then add that to -7, and you get -5. So our midline is -5 right there. So that is what we're going to put in for A. That will be -5. All right, then B is the amplitude, so the distance from the midline to the maximum or the minimum, either way. So that is going to be just the distance from either -7 or -3 to the midline, which is -5, and that distance is 2. So that's going to be our amplitude. C is 2 pi over the period. We already know what the period is. We can see how long it takes this graph to do one cycle, and that is 12 units on the x-axis. 2 pi over 12, which is pi over 6. And so C is going to be pi over 6. So phase shift. This function is not shifted because we're writing it as a cosine function, and it's starting off at its minimum. Cosine 0 is 1, which actually is the maximum of cosine. So it's not starting at its maximum, but it is starting at its minimum. So it's not really shifted left or right. It's just reflected upside down. So since it's starting at -1, its minimum, the minimum of cosine normally, we can just make it a negative cosine function and then we're done. It's not shifted, it's flipped. So we'll put that negative sign in our equation right here. Because when it's minus something cosine, that means it's flipped upside down, which is really what this is. And so now we can go ahead and write our equation. So it's going to be y equals -5 minus 2 cosine pi over 6 x.